Thank you, Elliot, and hello, everyone. My name is Michael. I'm really excited to present this project. This is a joint work with Dirk, who is sitting in the audience, and Tibor Heumann. All right, so the welfare implications of third-degree price discrimination or segmentation is kind of a classic problem in economics. We possibly all remember from our first course in economics, if you have a seller, they benefit from being able to divide their consumers into different groups. And each group has a different demand function or distribution of values. And actually, I would say we know quite a bit about the benefits of segmentation, the effects on not only consumer surplus, but also seller profits and social efficiency for the single good monopolist. We know quite a bit less, I would say almost nothing, about what happens when the seller can kind of simultaneously engage in second degree price discrimination, screening. So you think about the classic case of quality or quantity differentiated products. And we think this kind of situation is especially relevant, not only because second degree price discrimination is common, but because there seems to be some kind of interaction effect. So for example, if I want to buy the student discounted version of Microsoft Office, that's like a classic price discrimination case. My student discount only works for the base model. I don't get a discount on like the enterprise version of Microsoft Office. And so this pattern is very common. And so there seems to be some kind of interaction here between the two forms of price discrimination. So with that brief motivation in mind, I think the purpose of this paper is pretty clear. We're studying the interplay between second and third degree price discrimination with a particular focus on how and when segmentation benefits consumers. So our main questions is how does price discrimination, and now we approach kind of this combined form of second and third degree price discrimination, affect prices and welfare. I'm going to talk a lot today about what the consumer optimal segmentation looks like. And then also we want to think about, again, kind of the intersection of these two things, how the answer to the previous question kind of changes given that the seller is able to engage in screening. All right, so in the paper, we talk a lot about characterizing something we call extremal markets. So for time purposes, I'm actually not going to talk about that today. It's mainly an analytical tool for us to prove some, we think, interesting results. And so the results I'm going to talk about today, I'll make all of these more precise in just a few minutes, is first, in the consumer optimal segmentation, the price of the most costly good or the most costly quality increment goes down relative to the no segmentation benchmark or aggregate market. That in this segmentation, the consumer optimal one, low cost goods are bundled and high value consumers face no screening at all. And I'm going to give you a sufficient condition for the consumer optimal segmentation to actually be socially efficient and to feature no screening at all. So this is related to a pretty large literature on price discrimination and welfare. And I guess I'll have to add to it after today with Alexis's paper. I just want to flag, if you're familiar with the pair of papers by Nima Hakna and Ron Siegel, right, they consider kind of a similar setting, but the results I'm going to show you today are pretty much orthogonal and answer different questions. So with that, I'll jump into the model. I benefit a little bit from the randomness of the order, and that a lot of this is going to be a repeat from Alexis's part. But there's a single monopolist, and there's a continuum of consumers. So the monopolist sells capital I products. I index them by little I, and each of them has a marginal cost of production. And I'm going to order the products so that the marginal costs are increasing. Each consumer has a privately known willingness to pay V, which is drawn from some finite set. And each product is exactly identical to the consumer. They just generate utility V for the consumer. Consumers have quasi-linear utility, and they break ties in favor of the seller, meaning that they buy good I at price PI if and only if their type is weakly higher than the price. So if you haven't seen this before, this may seem like a strange model of second degree price discrimination. But basically, if you think about the goods as quality increments and the prices as like the marginal price of upgrading the quality of your good, then you've exactly recovered kind of the standard Musa-Rosen quality differentiated model. And so, and I will go back to this interpretation a couple of times when I go over results. All right, so a market is just a probability distribution over the set of possible consumer types, and we'll denote by this D function here the demand at a given scalar price. So the demand is just the proportion of consumers in that market that would be willing to buy a product at a given price. So given a menu of prices, a price for each good, I can compute the profit. It's straightforward, it's the demand times kind of price minus marginal cost, as well as the consumer surplus, which is the residual value conditional on purchasing the product. And then I sum these across all the different products and I get total profit and total consumer surplus. I say a price menu is optimal in market X if there's no other menu that yields a strictly higher profit. And so just to help maybe a little bit with visualization. All right, so imagine that there are 3 consumer types. I just call them 1, 2, and 3. Then I can visualize the space of possible markets as the 2 simplex. Here, I've imagined that there are 2 goods, cost 0 and 1/2. And what I've done is I've divided this simplex into different regions. And then within each region, I've labeled it by what the optimal price menu is. So something I want to point out is there are these 3 regions kind of near the corners where the prices of the 2 goods are the same. And so I'll refer to these as regions where the goods are bundled. Because they're priced the same, consumers either buy both or buy neither. And I may also refer to it as a region where there's no screening, since, again, the goods are bundled. Right, so segmentations for the remainder of the talk will consider some aggregate market fixed, and the aggregate market is the kind of the true underlying distribution of consumer type. And a segmentation is just a distribution over the set of possible markets subject to this majorization constraint that they kind of conform to the original aggregate market. This is like a feasibility constraint. Right, and the timing of the game, if you want to think of it, is that first, I consider some segmentation sigma of the aggregate market, and then within each market in the support of that segmentation, the seller is optimally setting prices. And so here I've drawn an example of, think of the blue dot as my aggregate market. It is feasible for me to divide it into these 3 red dots. There are some weights that make this conform to the blue dot. And here also notice that 2 of these red dots are in different price regions than the original aggregate market, meaning that for the consumers in these regions, in these 2 segments, the price of the goods has actually gone down relative to the original segmentation market. So I could imagine a scenario where I allow the seller to choose their favorite segmentation. The answer to that problem is not very interesting. It's first degree or perfect price discrimination, where the seller just selects all consumers of a certain type into one market, and then it can kind of perfectly price against that. So instead, we want to think about finding the consumer optimal segmentation, which is just the segmentation sigma that maximizes expected consumer surplus subject to these 2 constraints. First, feasibility, and second, that the seller is pricing optimally in every segment. This is a Bayesian persuasion problem, but I want to say that to our knowledge, standard Bayesian persuasion like concavitation techniques aren't very useful here. And one of the reasons for that is I've not imposed any kind of regularity constraints on the markets X. And so within these markets, you might imagine the seller is doing some kind of ironing. There can be some very strange things going on in order to derive kind of the consumer surplus function. Another thing is that, at least at this stage, I haven't even proven to you that the solution to this consumer maximization problem is achieved by a segmentation with finite support. So the set of possible markets is infinite, it's a simplex, and conceivably there could be some continuum of markets that I want to support on. In the paper, so we show that this is actually not true. We can write the solution, we can characterize the solution to this problem as the solution to some finite linear program, which in particular allows us to upper bound the number of markets I actually need to solve this problem. And then I say a segmentation is socially efficient if it maximizes the sum of profits and consumer surplus. If you want to think in terms of outcomes, that just means that every consumer consumes every good with a marginal cost lower than their value. So with that, I'm ready to talk about some of our results. So the first one is kind of a small warm-up result. So you take any segmentation sigma, and I claim I can find another segmentation, sigma hat, with the following 2 properties. First, it delivers a weekly higher consumer surplus. And second, in every market in this new segmentation that I've created, the price of the most expensive good, or for the quality interpretation, the last quality increment, is lower than it would be with no segmentation. I just want to mention that the cost of this last good may be different in the different markets. They're just all lower than this no segmentation benchmark, and other goods may become more expensive. So very quick intuition, right? In order to lower the price of a good relative to the aggregate market, I need a higher proportion of low value consumers. That's the only way I can convince the seller to lower their price. But how much more I need depends on the cost of the good. And so what might be optimal from the perspective of like social planner maximizing consumer surplus is I actually raise the price of some good in some market in order to generate slack in the constraint, and then I can lower the price of a costlier good in a different market. But of course, this logic doesn't apply to the last good for which there is no costlier good to lower the price of. All right. So for the second set of results, I'm going to make kind of an expositional assumption that the marginal cost is convex in I. I don't actually need this, but it does make the results easier to state. So this is take any good I, and then in the consumer optimal segmentation, I claim every consumer with a sufficiently high value consumes good I in every market. And what do I mean by sufficiently high value? So first of all, the value must obviously be larger than the marginal cost of production. The seller will never sell at a loss. But there has to be some additional gap. And the size of the additional gap depends on the index of the good I, as well as this term, which is related to the convexity of the marginal cost. All right, so this theorem is nice, but for the main takeaways, I want to take two immediate, actually first, I give it kind of an intuition for the result. So if I imagine a market where there's kind of screening between goods I and I+1, meaning that they're being sold at different prices. Again, taking the perspective of like a social planner, I could distort the market so that now the seller sells both at the lower price, PI. But obviously this isn't free because of the feasibility or constraint. And basically the closer that PI and PI+1 are, the smaller the distortion I need to make this change. And the larger that the consumer value is, the larger the sort of benefit that I get from making this distortion. So when V is relatively large and these two costs are relatively close, it's always optimal for me to make this distortion. So kind of two corollaries that I think are more interpretable. The first is, as I mentioned before, that high value consumers are not screened, that low cost goods are bundled together. And so this first corollary, I just take the theorem from before. On the right-hand side, I replace the little I with the big I, and I note that every consumer with a value or a type that's sufficiently high relative to satisfying this inequality consumes every good in every market. So if we go back, if you think about kind of the quality differentiated goods example, something that you might notice with segmentation is if I'm a high value consumer and I'm kind of randomly placed into these segments, my outcome might change based on what segment I'm placed in, right? I might get unlucky or lucky. But actually, if my value is sufficiently high, I'm a very high value consumer, it doesn't really matter what segment I got placed in. The price I face might change, but I will always be consuming every good or the highest quality good. And the second one is you take the theorem from before and you replace the left-hand side with V1, which is the lowest possible value that the consumers can take. And then any good that satisfies this inequality is bundled in every market, meaning that they're all sold at the same price in that market. Again, that price could be different between the markets, but it's the same within the market. And so kind of the interpretation of this result is that in the consumer optimal segmentation, and actually this argument holds for any segmentation along the Pareto frontier of achievable surplus divisions, but in the consumer optimal segmentation, for goods or quality increments that have sufficiently low marginal cost, the seller is actually not using all of its technology. The seller is not offering kind of the most inferior or most base level of the good. It always offers the consumer at least some upgrades. If I combine these two results together, I get the third result that I want to talk about today. All right, so if the lowest possible consumer type, or alternatively, if the entire support of consumer values is sufficiently high relative to all the marginal costs of production. And the consumer optimal segmentation involves no screening and is socially efficient. So what's happening is that every consumer is actually consuming every good in every market, just at different prices. And in this case, actually segmentation has completely replaced screening as a tool for the social planner. They don't use screening at all. And there's no trade-off between consumer surplus and efficiency. So something that you might notice is, as I just mentioned, when this condition holds, every consumer consumes every good in every market. And so you might think that what I've done is I've just presented a condition that recovers the single good case. You might think this is equivalent to a single good monopolist that just sells some aggregate good with some aggregate marginal cost and segments the consumers respectively. This is actually not true, and maybe surprisingly. And the reason this is not true is if you're familiar with Bergemann, Brooks, and Morris, you know that for the single good monopolist, moving from the no segmentation outcome to the consumer optimal segmentation, the consumers actually appropriate all the surplus gains, meaning that the seller's profit remains constant. That's not true in this case, where when we move from the no segmentation to the consumer optimal segmentation, actually both the consumers and the sellers benefit. They split the surplus gains somehow. All right, so that's pretty much all I have. I'll just quickly summarize. We look thinking about a monopolist who simultaneously engages in both second and third degree price discrimination. We're really focused on thinking about the consumer optimal segmentation, where the monopolists kind of optimally the prices within each segment. And we think our results provide some novel insight into kind of how these two forms of price discrimination